Hello everyone. In this video, we are going to discuss with a new topic, which is software engineering. In short, we call it as SC. Basically, this subject is more of theory oriented. You will not have any problems and will not have any derivations. Such things to remember. Everything is theory here. And the topic is evolution of software engineering. The evolution of software engineering is uh, in three types. And the first one is evolution of an art into an engineering discipline. And second one is evolution patterns for engineering discipline. And third one is a solution to the software crisis. Whereas coming to first one, evolution of an art into engineering discipline. See, evolution of an art into an engineering discipline. Over the past 60 years, software engineering has changed from an art into proper engineering discipline. In the early days, programmers follow and informal methods called build and fix. Here we can see in the early days of programming, after completion of developing a product, if there are any errors occurred, the software developers can build and fix that product again. He will check any errors raised. uh, to solve those errors, he need to fix that software until the user needs to satisfy, until the bugs need to clarify. So in this approach, software was developed without any clear requirements or design. In early days, the software have no clear requirements or any other design in order to develop a proper product. So the program was first built and then repeatedly modified until it works or satisfied the customer. In this method, depend mainly on the programmer's personal skills, institution, and experience. While some talented programmers produced good results, most software became costly, ineffective, and difficult to maintain. It also lacked consistency and scalability, meaning the software could not handle increased users or workload without losing performance. See here, while some skilled programmers created impressive results, in this approach lacked consistency and scalability, increased load but with the constant performance. Over time, the field evolved as researchers and professionals established a clear principles and systematic methods, replacing institution driven practices with well documented process that make modern software develop effectively, reliable, and collaborative. Whereas in previous days, there is no effective software in order to develop a product. Once he develops a product, he need to rectify and fix the errors until the errors or the user need to satisfy his requirements. But nowadays, a professional researchers and professionals and researchers introduced a systematic methods in order to develop a product in effective manner. And whereas coming to second one, evolution pattern for engineering discipline, we can easily notice that it has evolved from an historic art from to a craft form, and then slowly it has emerged as an engineering discipline. As a matter of fact, that this pattern of evolution is not very difficult from the seen in other engineering discipline. Where, for example, let us see that the iron making and paper making, software development, or building construction, evolution of technology has followed similar patterns. In this pattern, technology developed has systematically, it can seen in the figure that every technology in the initial stage has increased. You see here, first the art, which is historic use of past experience. Only a few programmers are there in earlier days. Later on, it became into craft, where the unorganized use of past experience. Later on, it became into engineering. where it is a systematic use of past experience and formulation of scientific basis. It is nothing, the figure describes that evolution of technology with time, how the software can change from time to time. Over time, the technology grows into craft where skilled workers begin to share their knowledge with others as more people learn and practice. The amount of shared knowledge increased day by day. Much later, the knowledge is systematically organized and documented and supported by scientific principles. At this stage, the technology becomes a true engineering discipline. For example, modern steel making development after scientific methods and proper documentation we introduced. The evolution of software engineering follows same pattern in the early days of programming. There were good programmers and as well as bad programmers. Good programmers know certain principles or tricks that helps them to write better programs, but they are rarely shared this knowledge. Gradually, these useful principles along with research innovations were collected, organized, and documented. This organized body of knowledge formed the discipline of software engineering. As today's software engineering principles are widely used in the industry and new principles are emerging rapidly, making it dynamic field. However, some critics argue that many lack of strong scientific foundation are subjective and sometimes insufficient to fully explain complex problems which are raised while developing a project. Uh, Next one. All good principles and tricks were discovered by programmers along with research innovations have systematically been organized into body of knowledge that forms the discipline of software engineering, where the evolution of software engineering has been a remarkable journey, which the first programming digital computer was developed during uh, early days. And next one is a solution for the software crisis. The software crisis refers to the increasing problems in developing and managing software efficiently. While developing a project, there will be problems occurred or raised. In order to solve those problems, what we need to do? The one major issue is the rising cost of software compared to hardware. Compared to hardware. However, today organizations spend much more on software. If this trend continues, we might reach a point where hardware is given free with software purchases. As we see here, in previous days, if we purchase a hardware, they will give software freely. But in present days, if you purchase hardware, the software doesn't give because the software is much more expensive as compared to hardware. If this trend continues, we might reach a point where hardware is given free with software purchases. This crisis is caused by factors like the first one is growing complexity of software problems, and second one is a lack of proper training in software engineering, and next one is a shortage of skilled professionals, and next one is low productivity in software crisis. Low productivity in software development. Uh, the solution for software engineering challenges is here we need to apply the methodologies like agile model, which it is flexible and it helps to collaborate, and continuous integration and continuous deployment. Automate testing and deployment process to improve efficient, and it helps to reduce errors. And next one is code review. Conduct regular code reviews to ensure high quality code and knowledge sharing. And next one is testing and validation. Implement thoroughly tested and validation processes to identify and fix defects early. And next one is documentation. Maintain accurate and up-to-date documentation to facilitate knowledge sharing and maintenance. Thank you.